Hello, ladies and gentlemen, Caymans. Mr. Eicher here, bringing lesson 2 from our chapter about probability and statistics. In lesson 1, we got to learn about two-way tables, and you'll see on your screen right now a two-way table. A lot of words here. It's pretty common in real-world math like statistics to have lots of words about things. So this question says, an AP Stats teacher asks his students when they typically are falling asleep during the weekdays of distance learning and how the amount of time they're spending doing distance learning work compared to the amount of time they would spend on the same course before school closed. The responses are shown in the two-way table below. So again, just to be clear what's going on, typical weekday bedtime during the school closure. So students who fall asleep between 9 p.m. and 10:30 versus a student who falls asleep typically from 1:30 to 3 a.m. So I asked my students this because I was interested and when they're falling asleep, because I know I'm going to bed a lot later than I usually do. Then I also asked the amount of time they spend doing work on AP Stat stuff. And I wanted them to compare with before. So, about the same amount of time. And I told them factoring in like the 80 minutes you'd sit in class plus the amount of time you do on homework. How does it compare? So I do appreciate the honesty, less time. A couple students said, I'm going to say less time, but that doesn't mean you're going to assign more homework, are you? So I appreciate that honesty. Okay, so there's our two-way table. We're going to answer several probability questions. We'll probably break this up into multiple videos since there's quite a few questions here. But thankfully, once you're able to read the table, the questions go pretty quickly, even though there's quite a few questions. There's also some vocabulary terms that I'd like to introduce you to in this lesson that we kind of used in the last lesson, but we didn't actually attach a name to it. Okay, so suppose we select a student randomly from this sample. There are 50 AP Stats students who took the survey. Find the following. Letter A. What is the probability that the student's bedtime is after 3 a.m.? So we need the total number of students who fall asleep after 3 a.m. So here's the 3 a.m. And it looks like there are 6 students who fall asleep after 3 a.m. So our probability would be 6 out of 50. I'm going to leave it like that. You can leave it as a fraction. I'm okay with that. Or you can get your calculator out and figure out what the decimal is. But I don't have my calculator handy, sadly. But it's 6 out of 50. And I'm okay if you don't reduce that. It's usually easier for me as a teacher if it's left in the original numerical values rather than say 3 out of 25. But that's correct. But it's really fun if you want to leave it as 6 over 50 in this chapter. Letter B, what's the probability that a student's typical bedtime is between 12 a.m. and 1:30? 12 a.m. and 1:30. Typical bedtime, 12 a.m. and 1:30. That looks like that right there. Typical bedtime. 12 a.m. and 1:30. How many students is that? That's 14 students out of the 50. So our answer would be 14 out of 50. If you want to write that as a decimal, you can. What is that? 28% or 0.28. But either way is fine. And then the next question we have, what's the probability the student's typical bedtime is before midnight? So before midnight, that would be taking the 9 to 10:30 students, and we need the 10:30 to 12 students, 10:30 to 12. So here we're going to add a couple. We have 3 students who are early to bed, early to rise. And then the 10:30 to 12 would be 12 students. So that would be 3 plus 12 out of a total of 50 students. So we have 15 students out of 50. So about a third of my class were going to bed before midnight. I'm guessing that would be a lot higher if we were actually in school and you had to wake up early to get to that 6 a.m. zero period class. Next question, D, what's the probability that the student says less time or more time? So that's this question. how long they're spending on distance learning compared to what it was before. So less time students, that would be this many students, less times 18, or more time, that would be 13. So that looks like we have a total of 18 or less time plus 13 or more time out of a total of 50 students. So that looks like it's 31 out of 50 or 62 if you wrote that as a decimal. I did underline the or here. That's going to be pretty important to connect that when we have an or question like this, we're going to be adding the outcomes from the table. So let's see another example, E. What's the probability that the student says 9 p.m. to 10:30 p.m. or after 3 p.m.? Oh, I guess that's a typo. That should say a.m. Okay, so the table has a little too much writing. Let's clear that. So we have the student says 9 p.m. to 10:30 p.m. So 9 to 10:30 would be 3 students. And then after 3 a.m. would be 6 students. So it looks like our answer would be there are 3 plus the 6 out of the 50. That would be 9 out of 50 students, or 18%. What type of events are the probabilities in D and E called? So the probabilities, we call these probabilities mutually exclusive probabilities. You've probably heard that term before in a previous math class, but if not, I'll introduce it to you. These are called mutually exclusive. You can't be both at the same time. Now, what do I mean you can't be both? Well, I mean, if you're going to say less time, you can't also say more time. You have to pick, is it less time or is it more time? You can't say typically you fall asleep from 9 to 10:30 and also typically you fall asleep after 3 a.m. It's one or the other. Now, on one given night, you could go to bed at one time versus the other, but if you're asked, like, what's your typical time you go to bed? You don't say 9 to 10:30 and 3 a.m. Like, it's one or the other. You don't have both at the same time. Other examples of mutually exclusive events are like picking a 12th grader versus picking a 9th grader. You can't be both a 12th grader and a 9th grader. So that's known as mutually exclusive events. Another way to think about it is that there's no overlap is a phrase that you might hear. That represents the no overlap idea, represents if here are all the students in the school and here are all the 12th graders, here are all the 9th graders, there's no overlap. Those two circles in that Venn diagram, there's no overlap. So these are mutually exclusive events. So a pictorial definition of mutually exclusive events is that Venn diagram. Okay, so let's check out G. What's the probability that the student's typical bedtime is before between, another typo, sorry about that, before 12 a.m. and, oh, sorry, I guess the before was the typo. What is the probability that the student's typical bedtime is between 12 a.m. and 1:30 a.m. or that they spend less time on distance learning? So let's think about this. First, let's figure out what students are falling asleep between 12 a.m. and 1:30. So 12 a.m. and 1:30 would be these students right there, 12 a.m. and 1:30. And let's figure out what students are spending less time on distance learning. That would be these students, less time on distance learning. Now, there's an issue here that we didn't have in the previous probabilities. And that issue is if you see where all these numbers are coming from, like this 14 comes from these students. There were 6, there were 15, there were, 5, and there were 3. If you add that up, you get 14. Where did the 18 come from? Well, that was this 3, these 6 same students again, 5, and then 1. So really, if we're just counting the students, we should get an answer of 3, 3, 6, 5, 1. 5, 3. So if we add those up, we would get, what's that, 3 plus 3, 6 plus 6 is 12, plus 5 plus 1 is 18, plus 5 is 23, so 26. We should get an answer of 26 out of 50. But look what happens if we just take these counts here. If we had 14 plus 18, 14 plus 18 is 32 out of 50. So that's a problem. These answers should be the same. So the problem is we double counted these students right here. We counted them as students who go to bed in this time span, and we also counted them again as students who are spending less time on distance learning. So it's okay if you're going to do this 14 and this 18, but there is overlap. There's 6 students who are double counted. So we have to subtract those 6 students to get 26 out of 50 is the correct answer. Let's see another example like that. Talk through that again, that issue. So let's say we have on H, what is the probability that the student's typical bedtime is, not before, other typo, is between 1:30 and 3 a.m. So 1:30 and 3 a.m. That would be these students, 15 of them. Or that they spend about the same time on distance learning. About the same time, that would be these students. Now, what's the danger of just doing 15 plus 19 out of 50? Can you see what's going to be wrong with that? Well, what's going to be wrong is if we add the students, we'd have 0, we'd have 0, 6, 5, 6, and 2. We'd have 5, 6 again, and 4. See how we double counted that 6? So these students, we counted them as students who go to sleep in this time range and who are spending about the same amount of time. So really, in our formula here, we should subtract 6 to get the right answer. So that would be 34 minus 6 is 28 out of 50. And that's what we should get if we add all those highlighted numbers. 5 plus 0, let's say that's 11, 16, 22, 24, 28. 28. That's what we got. So are these events in G and H that we just answered, are these events mutually exclusive? Well, no, they're not, because there's overlap. If you like the visual, you would have, here's all the students in the class. There's students who are going to bed from 1:30 to 3 a.m. And there's students who are spending about the same amount of time. That's the same amount of time. This is the 1:30 to 3. And there's overlap. There are 6 students who are both spending about the same amount of time and going to bed from 1:30 to 3. So these are not, so no, they're not mutually exclusive events. Because there's overlap, you can be both a student who spends, how do you spell that word again? Spends the same time, and you could be both, and bed at 1:30 to 3. So we would call these inclusive events, because one event is included in the other, that you could be inclusive. So they're not excluded from each other, but included, one included in the other. I think that's sufficient for this first video. We've done 9 questions there. And then that's a kind of a good place to transition, since these last couple are a different topic. So thanks for watching this video. You can give me a thumbs up if you liked the video, and catch me again on the next part, the next video, where we continue this table.